Welcome to the Jack and Jake talk. I'm Jake.
And I'm Jack.
This is where we talk about science theories and all of the above. Today, Jack, what are we talking about?
Well, today, Jake, we're talking about CAR T cell therapy. Um, this is something I don't know very much at all about. I'm still kind of getting educated on the field of medicine. So, what do you know about CAR T cell therapy, Jake?
I know maybe just like a tad bit more than you do, but probably not by much because I'm not a scientist. But I know someone who is a scientist who gave me, he had said that it's a interesting thing that we should look into or even find more about. So, if anyone doesn't know, CAR T cell therapy is a form of cancer treatment. And I'll give a very short summary of what it is. It'll show an image, just kind of like go over what I've been talking about. But so CAR T cells is a type of, to my understanding, immunal type of cell that, Jack, you know what the immune system is?
I do. Yeah, it's your body's natural way of fighting
Yep.
diseases.
Yep. So then you have the white blood cells and immune cells and pieces. So what they do with CAR T cell therapy is they take some of your blood and they strip out of the blood T cells. What they then do is take proteins or different pieces in a laboratory and plug those into the T cells that they took from your body. After they've got it correct, of the correct proteins are such that they want to put into those T cells, they then put it back into your body. And then those T cells, which are immune cells, they then will attack because they're specified by the pieces that they're put in. They will then attack your cancer cells to get rid of whatever the cancerous infection is. Now, they've had a few applications of how they've had success with on this, and specifically, I'm trying to recall, just pulling up for the specific types of cancer that they've cured with it. I guess not cured, but have had positive results with. I do believe one of them was leukemia. Come on, I know that I had it. This is terrible. Um,
So, just while we're looking
yeah,
for that, Jake, so
yeah.
just to be clear, this is taking your body's own cells from the immune system straight out of the blood, and you said it's adding proteins to those cells and then reintroducing them back into the body.
Sometimes they add specific proteins, and sometimes they add different pieces into it. Now they have not been had success or been able to adapt it um, to put on tumors type of cancers. That is a
Okay.
little bit more trickier for what they have to do with that. Um, but I believe it's 60% of the trials that they've used this process for have had positive results. Now, that's not great, but that's better than half. I don't know if you know, with cancer, it can be pretty difficult to pinpoint, chances or how someone's going to react to certain things. Something they also do before they infuse you with the T cells that they've created is you may have to go through chemotherapy just for a short period beforehand to prepare the body for getting T cells put in. If you'd like, I'll share a image that will show what I was talking about when it came to the of how the process goes. If I can share, can I share? Yes, I can present now. That's the button. Okay. I want to show, and come on. Let's see if it'll come up. Okay. Is something coming up, Jack, that you see?
There it is. Yep.
All right. So now you're seeing like a little bit different from what I talked about now. So you see the part where I don't know if you can see my mouse, but from the beginning where the plus sign is, so there's the T cell taken out from your blood. They then earn, it says gene, but they can also put proteins and other pieces in into your T cell. This CAR receptor is a little bit more scientific. Go away. Um, the if you want to, you can look more into what the chimeric antigen receptor is. It's another piece that I don't have as much knowledge on, but it's helping with the growth process. Then they infuse it, and as you can see in the other image, they're then specified to attack cancerous cells. Let's see if I then exit out of this. I want to stop sharing. Okay.
That's pretty amazing. So that's almost it's like a bioengineering solution instead of
Yep.
like more traditional medicinal methods. Very
Right.
interesting
And the
because
two
normally,
more,
yeah.
go ahead.
No, go ahead, Jake.
Oh, I was just going to bring up for sure the two most common forms of cancer treatment is um, chemotherapy and radiation. Those are the two kind of more common forms that are specifically even chemo. But this is another thing where, I mean, you're using, yes, they're genetically altered, but you're taking your own immune system using it to fight your infection, right? So that's one of the, I mean, the ways they've been trying to develop even further ways of genetically modifying it to be improving, right? Instead of that 60%. I know in specific, they've been trying to use it on people who have a very low chance, right, of unfortunately survival because they want to see how effective the pieces are. But that 60% was the last percentage that I saw on it. There are obviously side effects, just like any type of treatment. Um, One of the pieces that when T cells go into your system and then attack is they produce something called, I'm going to mispronounce this, or I may say the incorrect thing. Apologies. Cytokines. It's just a type of thing that's released so that they can get into certain parts of your body and attacking the immune cells. That can create reactions where people you can get fevers, nausea, getting sick. It's your body reacting to the fact that, hey, something's attacking it. And then also with it, some people get a little dizzy and delusional because of the reactions that are going on with the T cell attacking the cancerous cells. I know this isn't uncommon even when it comes to radiation or chemotherapy. A lot of those are similar to when someone goes for chemo and radiation. But positive wise is we have another, the article that I read was from 2022. There's also talks of it back in 2017 that there is more, they tried to do more development with it. So this is like another way, positive thing that we can do to help provide a form of treatment for cancer, not a foolproof, because unfortunately, I hate to kind of laugh. Unfortunately, we don't have a foolproof way yet where you can just do something and then cancer's gone forever. Because even when someone says that someone's a cancer survivor, you're more of a cancer recovery because you can just about get rid of it. But there's always a chance that it may come back, even from another form is where they just do a removal, where they remove whatever the tumor is. or whatever piece of the organ is that is cancerous. They cut it out, and after they do more chemo or radiation to that area, um, hope that the cancer is gone. Yeah.
That's really interesting. So I know with the body's immune system, as well as the cells in your blood, you have the red blood cells which carry the oxygen, and then you have the white blood cells which are the immunity response, right? The white blood cells
Right.
attack pathogens in the body system. So what are the T cells, Jake? What makes them so special, and why do we use them for this kind of therapy?
Specifically, I tried to find that answer out, but it was tricky to find specifically why they used the TISA. Maybe because it's easy to alter and easier to put back into the body, for the body to recognize it. That may be a certain reason. Like I said, I couldn't find the specific reason of why T cell in specific. Um, but it is an immune based cell. So perhaps they went through trial and error. Um, so yeah. Oh, I found the question that I was trying to figure out earlier. So initially, when they developed CAR T cell therapies, they focused on the most common cancer in children, which is acute lymphoblastic leukemia, ALL. Um,
And
so
leukemia
majority,
is a blood cancer, right?
yep.
Okay.
So yeah. Um,
Yeah, I remember you said this therapy isn't particularly useful for cancerous tumors, but it's maybe better for more like dispersed cancer types.
yeah. Mostly dispersed types because they're thinking, what about something like, if you're looking at a larger tissue piece of, like, say, brain cancer or something like that. Well,
Mm-hmm.
in order for it to um, get into, now again, this is really, really outside of my so this is what my understanding was of it. Um, was that, so getting it directly into bloodstream, right? Some of the cancers like that, it's easier with this TISA because you just simply infuse it into someone and let it do its thing.
Okay.
But going into a larger organ and getting into they've been trying to develop a different way with this T cell to get into um, organs or a specific part of the body. Um, but we got a pretty complicated body, right? Well, to get into that part, it can be really tricky. Specify. Um, yeah.
Gotcha. And you said the symptoms were, it kind of sounded like they were similar to the natural immune response, right?
Mhm.
Fever, nausea, that sort of thing. Like when
Right.
you have a cold and your body's fighting through it. Is it more severe than the typical
It seems like
immunological
it's
response? Or
it seems like it's much more severe.
okay.
Um, but they said initially, even if your body is starting to say have a fever, you're feeling nauseous, whatever, that means that your body is reacting to it,
Hmm.
which they said is a, again, this is from this information I all got was cancer.gov, so government website on cancer. Um, means that your body is fighting something, um,
So
which
it's
they said they
bad
wanted.
symptoms, but it's a sign that maybe it's working.
Yeah. Another kind of on what other piece of the puzzle I was going to talk about. Um. Oh, so when you had asked the question about larger organs and why we're unable to, so there's a one of the things that comes up is something called tumor heterogeneity.
Okay.
So solid tumors that are cancerous can be different from patient to patient. So, like I said, patient to patient, it can kind of be difficult. Um, that's about as far as they kind of went with saying about that. Um, yeah, I know that's not really helpful, but yeah. um, but yeah, I just know with knowing people who've gone through cancer and knowing families and people as well, like I wouldn't say it's full relief, but it's encouraging to know that there's another form of cancer treatment that's out there other than just the I guess instead of the top two, there's the top three, which is chemotherapy, radiation, and then removal has a specific name to it, which is for some reason escaping me. But where they take out whatever piece, whatever organ or what have you that is cancerous and hope that it goes away. Yeah.
Right. Well, it sounds really promising. I mean, potentially 60% success rate in trials. I mean, for a cancer treatment, that's pretty huge.
Yep.
And I mean, it sounds like the impact on the body. I mean, surgical removal of tumors, any kind of surgery is, pretty taxing on the body. Chemotherapy and radiation therapy, I mean, potentially very tissue damaging, not just to the cancerous tissue, but also the healthy organs and whatnot too. So, some kind of therapy that uses the body's, typical, pathogen resistance it's that effective. That's really impressive. Yeah.
Right. And like I said, I mean, they've been trying to apply different ways with the T cell since even 2022 for this therapy. And I think, to me, the most intriguing part of this is that they're already taking a part of your own natural defense, tweaking it, to whatever tweaking they need to, and then putting it back to you so that it's like, hey, well, it was a part of me already to attack what problem I have versus using chemo and radiation and just removing it. I just find it really, really interesting that they're like, well, the immune system on its own does a pretty good job of fighting a majority of the things that we become unwell with. Why don't we just use what we have already? If you have, it's like, in a toolbox, right? If you have the tools, why would you? I mean, it's important to go out and buy another tool, but if you have a toolbox and a tool that works pretty well, then why not try and use that? I mean, we've all jerry-rigged things, right?
Oh, yeah.
To try to fix some problem.
Just curious, Jake. So when they implement this CAR T cell therapy, is it something that works through, within like a few weeks, or does it take months or years of this treatment? Like what's the timeline look like for this?
So timeline. Now you're
Or
catching
maybe
me
it
up.
varies by patient to patient even.
I believe it varies, just similar enough when it comes to chemo and radiation, right? They can apply it a certain amount of doses or time period on it. To you start small, right? With a small
Hmm.
form of a dosage, and then I can imagine with the trials and the research they've done that there must be some point where maybe some down the line they're just like, okay, we can't keep, you know, destroying, I guess not destroying, but having so much of a negative effect on the person's health by using this. Yeah,
Gotcha.
yeah.
Yeah.
So that part, sorry, I just had remembered. So that in that diagram that I showed you, the chimeric antigen receptor is the receptor that's put in so that it can enter. I don't want to say the wrong thing, so I'm just going to stop.
Well, it kind
Because
of
I
looked
just,
like from the diagram, it looked like those receptors almost latch on to the cancer cells.
probably that piece.
Some kind of
Like I
way
said, I've
that it.
stated more than once, I'm not a scientist, I'm not a doctor.
Well, I mean, it's complicated stuff. I mean, that what was it? Chimeric antigen receptor. I mean, that
Yeah.
by itself, that's three complex words that needs a little bit of breakdown. But
I
you need
mean,
a
chimeric sounds
biologist and
pretty
a
cool.
doctor and a genetic engineer, and yeah.
Yes, and I know the geneticists would go very in depth on talking about it. Yeah.
Yeah, that was my last question, Jake, was
Yeah.
for this kind of therapy. I mean, it seems like there's a lot of research and development that had to go into this. I mean, is there a treatment, price tag attached to this sort of therapy? How's it compared to other treatments out there? Is it something that's viable for the average cancer patient, or is it going to be pretty pricey?
No, I don't know what other cancer treatment costs are, but I did find out how much on average what this costs is $450,000 to $1 million.
Wow.
So not cheap.
That's a lot, but I suppose if it's a treatment to keep your life going for a few more years, I suppose it's worth
Yeah,
it if you can
and
afford
there
it.
was like especially with the kids with leukemia. Um, there were some of them that lived 5 years longer than expected because they used this treatment. I
Hmm.
mean, I know it's a positive and a negative scenario, right? Um, but if you can improve someone's life at least for a little bit instead of them suffering, um, yeah. And now that you had asked that question about the average cost, now I had to look it up. Okay. Now this is coming from, it says the Mesothelioma Center is the first thing that pops up when I just put cancer treatment cost. It says about 150 grand.
Okay, so maybe several times more expensive, but still in the same ballpark, at least on the lower end.
Yeah.
Okay.
But even that, and this isn't rationalizing, saying that, oh, well, that, if this is better, then we have to do this, even though it's more expensive. I mean, um, I don't want when you're a family that is running into things like this. There are organizations that you can go to that can assist you with this cost and stuff like that. And it is very expensive for these treatments because they're pretty advanced in the science and what it takes to. I mean, even people being in the hospital, they're in weeks, if not months, um, being in hospital, and that cost adds up. So that's probably also where that cost comes as well. Not so much the treatment part, but being in a
Mm,
facility, having a doctor, nurses, that piece as well. So, and I'm trying to keep as positive with this as well, just because I just think it's great that there's another option versus someone saying to you, well, you have A and B. And if someone said, well, A and B are, both 20% chance that you're going to survive, right? What if you had another chance that was, another, it's to have choices versus not.
hmm
Yeah. Again, it's positivity, man, especially in the world of when some, cancer wise, you got to be positive
Yeah. Yeah.
wherever
Well,
you can. Yeah.
I suppose too, I mean, the overhead cost for the research,
Mhm.
it's always going to be high, but as the therapy method improves and becomes cheaper to actually implement, I imagine that cost will maybe come down over time if it's proven to be an effective treatment. It'll probably be more widespread too. No.
Yep. Yes. Good things. And I know there will probably be a day in the future, right, where someone's going to figure out the 90% solution, right, where there's that 10% worst case scenario. But when that day comes, it'll be very positive, and I know I said positive again, but a very exciting day, right, in the world. You know what they should also figure out too is how to get rid of the common cold.
Yeah.
Just strike that one off the board, right? I mean,
Wouldn't
I would
that be
choose
nice?
cancer first, but common cold, I mean.
Well, we did it with some illnesses. I mean, polio's basically gone.
Yeah.
Yeah. So
Yeah.
someday.
There will be a day. It'll be a fantastic and whatever team, individual, organization, company comes up with it. Thank goodness for them. So I think that about does it. Jack, what are we talking about next time?
All right, Jake. Next week we're going to talk about doppelgangers. We'll see how that goes.
Twin who's not a twin.
Exactly. Your evil twin that you never knew existed until you happened to see them down the street.
You're the person who's been causing me so much trouble. All right. Thanks everyone for listening.